In this video, we're going to talk about persistent data. When we write programs, we are creating data sets that allow our user to create data, to manipulate data, to store information, things like that in our program. So when the program ends, up until now, our data has just gone away because the program ends, all of our data is stored in memory. And then when the program ends, it just gets purged from memory and it's gone. But we want to be able to persist that data so that the next time we execute the program, the data that we had from before is still there, and we can continue to operate on it. So we use some type of storage medium to persist data between executions. Typically in a large application, you'll have some kind of database, MySQL or SQL Server. These are two types of databases. There's others besides these. These are very robust, and they're used, by huge servers and huge systems, thousands of users. For our CSV file, these can be used for small projects. They are useful for experimentation, for learning, and so forth. Or typically you would see these if you're sending data between programs. So if you wanted to create a file and then give it to a customer or a client that they can then load that into their system, then you might use a text or CSV file. But we're going to do this for our purposes because it's simple and it's a great spot to learn. So a CSV file stands for comma separated value. And so each row in the file is a single record of data. So if you think about our car lot example or something like that, then what we see is each car that's on the lot is a row in the file, and then each column in the row is going to be a value that represents one of the fields or the properties of our car, and then they're going to be, each of those fields is going to be separated by a comma. So sometimes CSV files have headers. So you see this is an example of a CSV file with no header. Just the first record is the contact information. So there's the name, and then it looks like a phone number here. Here's one with a header. So if you are moving data between systems, then you can declare a header row, and then this gives a name to each column. And this allows the program that's consuming the data to be able to know what order the data is in, and then you can do a lot more manipulation of the data if you have these headers. We're not going to use headers in this example, but know that there's a lot of value in doing this if you are writing more complex systems. So there's a couple of gotchas. So what if you're using a comma separated value and your data has a comma in it? Okay, that would be a problem, right? So there are ways to deal with that. So, but we're just, in our class, we're just going to not use commas in our data, just to make it simple. Sometimes from outside the US, they're going to use a semicolon instead of a comma. Just be aware of that. We're not going to do that in this class. And then also sometimes strings are enclosed in quotation marks. And we're using escape characters and things like that if there's a quotation mark in your or if there's a quotation mark in your data, et cetera. So just in this class, we're just going to keep it simple, and we're not going to do any of these things, just to keep it simple. So typically you would have a library that's added to your program. So CSV file processing has been written, it's been perfected, and there's really no need to write it yourself. So if you were doing this for a professional app for a client or for a business, you would probably just use a pre-developed CSV processing library. We are not going to do that because we're trying to learn how to do this. And so we're going to use these three Java classes, a file, a buffered reader, and a file reader, and a buffered writer and a file writer that go the other way. So we're going to learn how to do this, but just know that this type of CSV processing, you would typically use a library that would do these things for you. But for our purposes, we're going to do very simple steps to learn how to do this. So what we're going to do is we're going to, in our tests and our learning, we're going to read all the data from a file into our data structures, which is an array list. Okay, and it's going to be So we're going to create a list of cars, and we're going to add it to our array list. And then that's all going to be in memory. We're going to do processing on that data. We're going to show the inventory. We're going to change the mileage, things like that. And then if the data has changed, we're going to save the contents back to the file. So this is very inefficient when you have really large data sets. If you have millions of records, this does not work. But if you have, for our example, we just have, a handful, this works just fine. So this is how we write data. We use three imports. We use a file writer, and a buffered writer. The file creates a link to the file in your computer. So your computer has a directory structure. The file is an object that creates that link into the directory structure. So the file object knows how to find that file on your computer and how to open it, etc. File writer. This is a built-in Java class built into Java that allows you to write one character to a file at a time. And then the buffered writer is a wrapper class on the file writer that allows you to do things like append. So it makes it a lot easier to write lots of data into the file. So we're going to use all three of these together. So here's how it looks. You have a file name called my data.csv. So you need to be aware of the file path in your data. So in this case, this is /. This means this is a notation that says use the current directory. So this would be whatever directory the program is running in. That's where the data file would be. So, but you need to make sure that whatever file name you use, that if you're in our IDE that we're using for this class, it's built into the IDE. But if you're using Visual Studio or a NetBeans or one of those, you need to make sure that you have awareness of where the executable of your program is, and that you know where the file is being written. You also have to make sure that whatever path you put here, that you have permissions to actually create a file in that directory. So this is called a relative path. The // means start in the current directory, and then write a file. So you can do // which means go up one level in the directory, but those are all relative path names. You can also use absolute path names. If you're using Windows, it might be C:\data/ whatever. So, but just be aware of the path name here. This is for our examples using this // or in our IDE. There's a mechanism to do this that we're using for the examples, and we'll see that. Just be aware of your path name here. Okay, so then you can create a file called, we're going to say it's a file equals new file name. And so the file name is this. This just creates the file object, just like any other object, like creating a scanner or creating any of the other objects that we've created. Then we're going to use a try catch block use in the writer here. So we're going to say try, and then we're going to open with the try. We're going to say var writer equals new buffered writer, and then that's going to be created with the new file writer, which has the file. So this is a stacked three object stacked. We'll be interacting with the buffered writer. That's the one we're going to use, and the buffered writer will use the file writer in the file for us. Just know that our interaction will be with the buffered writer. This is kind of a unique approach to the way that we've created the try catch block here. You see, we've got try here. We've got this definition, kind of looks like you would a while loop or an if statement where you have a Boolean expression. This is a definition of a variable, in this case a writer. This is an external resource that's connected to the file system on our computer. So it's got requirements. We have to make sure that it's closed properly and things like that. So by wrapping it in a try block in this manner, we are able to create the writer, and then when the try block ends, the writer will close itself, and there'll be proper error handling and so forth if we do that. So then we create the writer, then we do a for loop, and in this case we write the data. So we're doing a for loop on items, and then we say writer.append, and then we give it a string. So in this case we've built a string method into our item class called toCSV, which creates a comma formatted list of the comma formatted string of the item attributes that we need to save. So this, whatever you put here in the append, this will be dependent on your program. So you'll have to figure out what goes into the writer.append. The rest of this is going to be identical in every program. It's really just going to be this piece right here that's going to be different. What do you write to the file? Okay. Once you're done with the writer, you want to close it. And then you want to have a catch here. So you want to, the error we're going to catch is an IO exception. This is a broad exception. Really, any kind of error that happens, the file is not found. There's no permission. You know, whatever the error might be, all of those can be caught by the IO exception. There are sub exceptions here. So if you want to catch a specific one, like a permission exception, then you can use a different exception name to catch that. But in our case, we're just going to catch just the IO exception when we go to write. Okay. Then if we get the message, we print out a little error message, and then this e.print stack trace. E is the variable that the exception is being stored in, and this print stack trace, that just prints out the error message so that we can see what happened, so we can debug our program. Okay, so this is writing data. So like I said, this little snippet of code will be pretty much the same thing you use every time you open a file to write. You'll use this whole block right here, and just change this one little piece which says, what do I want to write? Okay. The 2 CSV that we implemented. So in this case, we have a class called item. We've implemented a public method called, which returns a string called 2 CSV, and it just gets the description, and then it puts a comma, and then the price, and then it puts a new line. Couple of gotchas here. You want to know spaces with the comma. If you put a space in between the comma, that becomes part of your data. So you want to make sure that there's no spaces around the comma, and then you must put a new line at the end. Okay, if you don't put a new line at the end, all of your data will be on one row in the file, and you won't be able to parse it back when you read it. So always make sure you put the new line at the end of your string. Okay, so to read, you use similar structure, but instead of using buffered writer, you use buffered reader. So this is the same types of objects. They're just called readers instead of writers. Okay. The buffered reader uses a read line. We're familiar with the print line, but we're going to use a read line here. This is or the print line for system.out. We use the next line for the scanner. For the buffered reader, we're going to use a read line. This will read one row from the file, basically from the point where the cursor, where the file pointer is, to the next new line character. Here is the data. Here's the code, rather. This looks very much like the buffered writer. So we define our file name, we define a file, and then we do a try. Instead of declaring a writer, we declare a reader. New buffered reader, new file reader with the file. And then we wrap this in the try catch block the same way. The catch here is the same IO exception. There is a reader here. There is a file not found exception that you could use. So if you, in certain cases, maybe with the first time the program runs, the file isn't found because we haven't created it yet, then you want to, you can catch that file not found exception and separately from all the other IO exceptions, so that your code can, you can handle that error differently than others. And we'll see that in some examples. So then we begin to read. So the way we read is we declare a string variable that we're going to read into, and then we do this kind of special while definition. So we say while row equals. So notice how this is a Boolean expression, but it's a compound expression. So the first thing we want to do is this one expression, row equals reader.readline. That's, so we see in the parentheses how that's there. What this is doing is it's attempting to read from the file. If it's successful, then it's going to put the string data that it read in this variable row. If it's not successful, then it's going to return a null value. Okay. And if it is successful, it puts the data in row and it returns not a null. So we can do kind of a special while loop here that says read some data. When we get a null value here, that means we're out of data, and our program can end. So our while loop will end. We'll then close the reader, and we'll go on with our program. Once you have the data from the file that's read, you need to create an object out of it. And so my approach is to create a new to create a second constructor in our data class. And so this case, we're calling item with a single variable called row, and this is the comma separated data that we're reading in. So here's what the constructor looks like. So there's two variables in our item, our two fields. It's a description and a price. So the description is a string, the price is a double. So what we want to do is we get row, and it's going to have a description and a comma, and then the price, and it's all going to be in string format. So first we want to do is split that row into individual strings. So we use this split function that's on the string, and we want to split it at the comma. So what happens here is we had one string in row. We then get one or more strings in columns. This is an array, and this is columns in this the left bracket and open bracket and close bracket. And so we then get in this case there will be two columns because we expect a description and a price. The commas, the split method will discard the commas, so they won't be in our resulting data. Then we want to do a little bit of error checking. In this case, we're expecting two pieces of data, so we're going to say, hey, did I get two pieces of data? Columns.length is not equal to 2. Then we can throw this exception that says, hey, I got the wrong number of columns. Okay, so this, I don't know what this data is, but I don't have enough data, or I have too much data to create an item. Okay. Then we say take the first column and put it in the description. That's just a simple string assignment. The second column is a double, and so we want to do a little bit of error checking on that, because we're going to have to parse that into a double using the double.parse double. And then if it doesn't parse, then that's not valid, and we need to go ahead and throw another exception. So this is just protecting our program so that we're not reading that data in. So if I'm expecting a string and a double, and I get two strings, or I don't, or I have 3 or 5 or 10 columns in my data, then I'm going to say I don't know how to process this. Okay, so we'll write this in. So this is very simple. This is really easy to do in our code. It's really the same approach to every class that we want to read and write to files. Okay, we'll do some exercises in subsequent videos.